Dividing polynomials. So one of the things we want to take a look at is long division. If you recall way back in the 5th grade when they taught you how to do numerical long division, you had something like this where they would ask you, well, what's 21? How does 21 go into 672? So the first thing you would take a look at is you would start with, well, how many times does 21 go into 67? So you think about it, and okay, 3 times. So 3 times 21 is 63. So you'd write 63 there. And then you would take a remainder. You would subtract 63 from 67. You'd get 4 as a remainder. And once you got your remainder, you'd go to the next column, and in this case, bring down the 2. Then you looked at how many times 21 would go into 42. When you think about it and say, okay, twice. So you put the 2 up on top, multiply 2 to 21 and get 42. You'd write that down here, subtract them, and in this case, you have no remainder. Well, we want to use the same concept to work with dividing polynomials with long division. So in a case like this, where we're looking at 2x plus 1 into 6x squared plus 7x plus 2, the first thing we want to look at is we've got this 6x squared here. And we want to ask ourselves, what do I need to multiply to 2x to give me 6x squared? Or another way to look at it is we could take that 6x squared, divide by 2x, that gives us 3x. So if we multiply 3x to the 2x, we'll get our 6x squared. So we write 3x up on top here. Notice we do that in the x column. We distribute now the 3x to the 2x plus 1. So 3x times 2x is 6x squared. 3x times 1 is 3x. So at this point, we're ready to take a remainder. So 7x minus 3x is 4x is our remainder. And we start the process again. So now we have this 4x, and we ask ourselves, well, what do we multiply to 2x to give us 4x? Or again, another way to look at it is 4x divided by 2x gives us 2. So we put the 2 up top here in the constant column. Distribute the 2 to the 2x plus 1. So 2 times 2x is 4x. 2 times 1 is 2. Take the remainder, and there's no remainder. So whenever there's no remainder, that means that the divisor is a factor of the expression. So in other words, here on the numerical side, since we have no remainder, 21 is a factor of 672. Here with the polynomial long division, since we had 0 or no remainder, that means that 2x plus 1 is a factor of 6x squared plus 7x plus 2. Here they want us to use polynomial long division to divide 4x squared plus 23x minus 16 by x plus 5. They want the quotient and the remainder. So we want to set it up to see how many times x plus 5 goes into 4x squared plus 23x minus 16. All right, so again, we ask ourselves, what do we need to multiply to x to get 4x squared? So the answer to that is going to be 4x. So we're going to put that in the x column. I'm going to distribute the 4x to the x plus 5, and we'll get 4x squared plus 20x. Okay, we want to take a remainder now. Now, when you take in a remainder, you want to be really careful. If you get the wrong remainder, it's going to carry the mistake through the rest of the problem. So a simple way to make sure that you get the right remainder is to take the bottom expression and change the sign. So 4x is positive here, we're going to make it negative. 20x is positive here, we're going to make it negative. So change the signs of the bottom expression before you take your remainder. So now the 4x squareds eliminate one another. 23x minus 20x is 3x, so we have a remainder of 3x. Now we're ready to bring down the number from the next column, which is negative 16, and start the process again. We're going to ask ourselves, what do we multiply to x to get 3x? Well, if I multiply a positive 3 to x, I get 3x. So I'm going to distribute that 3x to the x plus 5, and I get 3x plus 15. Okay, I want to take a remainder. So again, so I don't make a mistake, I'm just going to change the signs on the bottom. So the 3x will eliminate, and negative 16 minus 15 is negative 31. All right, so they want to know what is the quotient and the remainder. Well, the quotient is the 4x plus 3, and the remainder is negative 31. Okay, here they want us to use polynomial long division to divide 3x squared minus 29x plus 56 by x minus 7. Again, they want the quotient and the remainder. So we set it up. X minus 7 into 3x squared minus 29x plus 56. All right, so we're asking ourselves, what do we multiply to x to give us 3x squared? So that would be 3x. I'm going to put the 3x in the x column here. Distribute the 3x to the x minus 7, and I get 3x squared minus 21x. Okay, remember to change the signs on the bottom. So this will become negative, this will become positive. And now we're ready to take a remainder. The 3x squareds eliminate each other. Negative 29x plus 21x is negative 8x. Okay, we have a remainder. We're ready to bring down the 56. Start the process again. Ask ourselves, what do we need to multiply to x to give us negative 8x? So that would be a negative 8. I'm going to put that in the constant column. Negative 8 times x is negative 8x. Negative 8 times negative 7 is positive 56. Change the signs. This becomes plus. This becomes minus. Everything eliminates each other. So we have no remainder. So here the quotient is 3x minus 8. And the remainder is 0. Okay, so here's something that's a little bit different than what we looked at. You notice that you have an x squared plus 1. And if you think about it, what's missing is a x to the first power. So if there's something missing in the expression that you're looking at, because all the exponents need to be in descending order, if you don't see one, you have to create a placeholder for it. So in other words, if I'm dividing this, I need to set it up so that I have x squared plus 0x plus 1. Okay, so that missing x to the first power that's in the expression, I'm replacing now with a placeholder. That's got to go into, so we have x to the fourth, x to the third, x squared. Again, we're missing an x to the first. We're going to have to put a placeholder in for it. So let's write that in. 3x to the fourth minus 4x cubed plus 12x squared plus 0x for the placeholder, and then plus 5. Okay, so once we have the placeholders taken care of, we just do the same thing that we've done with the previous problems. So we're looking for something to multiply to the x squared that will give us 3x to the fourth. So 3x squared will do that. I'm going to put that here in the squared column. So 3x squared times x squared is 3x to the fourth. 3x squared times 0x will give us 0x cubed. And 3x squared times 1 will be 3x squared. Okay, we're ready to change the signs and then take a remainder. So this becomes negative, negative, they all become negative. Okay, 3x to the fourth, so eliminate one another. Negative 4x cubed minus 0x cubed is going to give us a negative 4x cubed. Okay, and then 12x squared minus 3x squared will give us 9x squared. All right, we're ready to bring down the next column. That's a 0x. All right, so now we're looking for something to multiply to x squared that will give us negative 4x cubed. So that's going to be a negative 4x. So negative 4x times x squared, negative 4x cubed. Negative 4x times 0x will be a negative 0x squared. And negative 4x times 1, negative 4x. Okay, change the signs. So positive, my colors aren't working today. Positive, positive, and positive. All right, so now negative 4x cubes eliminate one another. 9x squared plus 0x squared is 9x squared. Again, colors don't want to cooperate. 9x squared, and then 0x plus 4x plus 4x. Okay, ready to bring down the next column, positive 5, and I'm looking for something to multiply to x squared that will give me 9x squared. So that'll be a 9. So 9 times x squared is 9x squared. 9 times 0x is 0x. And 9 times 1 is 9. All right, we're ready to change the signs. Okay, and so 9x squareds eliminate each other. 4x minus 0x is 4x. And 5 minus 9, negative 4. Okay, so they want to know if x squared plus 1 is a factor. And since we have a remainder, it is not a factor. We have to have a remainder of 0 for it to be a factor. So since we have a remainder of 4x minus 4, then x squared plus 1 is not a factor. Okay. All right, here they want to know, is x minus 2 a factor of p of x equals 5x to the fifth minus 32? If it is, write it as the product of two factors. Okay, first we need to find out if it's a factor. We need to see when we divide, did we get a remainder of 0 or something else? If we get a 0, we know x minus 2 is a factor. So we need to set this up. So I have x minus 2. Okay, now I have x squared, x to the fifth minus 32. Got a lot of placeholders to put in. So I need something to the fourth power. So 0x to the fourth. I need something to the third power. I need something squared. And I need something to the first power before I write the constant in, negative 32. Okay, so we're ready to divide. So we have to figure out what we're going to multiply to x to get x to the fifth. So that will be an x to the fourth. So I'll put that here in the fourths column. Distribute the x to the fourth to the x minus 2. I get x to the fifth minus 2x to the fourth. Okay, ready to take a remainder. So we're going to change the signs. So our remainder here will be 2x to the fourth. bring down the next column, 0x cubed. Now I need something to multiply to x to give me 2x to the fourth. So that's going to be 2x cubed. So 2x cubed times x, 2x to the fourth. 2x cubed times negative 2, negative 4x cubed. Okay, change the signs. And we're ready to take a remainder. So our remainder is going to be 4x cubed. Bring down the 0x squared. Now we need something to multiply to x to give us 4x cubed. So that'll be 4x squared. Multiply 4x squared to x, I get 4x cubed. Multiply 4x squared to negative 2, and I get negative 8x squared. Okay, change the signs before we take a remainder. Okay, so 4x cubes eliminate one another, so we have a remainder of 8x squared. Okay, ready to bring down the next column, 0x. And here we go again. Need something to multiply to x. That's going to give us 8x squared. That's going to be 8x. All right, so now if we take the 8x and multiply that to x plus x minus 2, we're going to get 8x squared minus 16x. Okay, before we take the remainder, remember, switch the signs. This becomes negative, that becomes positive. So our remainder then is going to be 16x. Ready to bring down the negative 32. Okay, need something to multiply to x to give me 16x. That'll be a positive 16. Multiply that to x minus 2. I get 16x minus 32. Change the signs. Everything eliminates, so I have a 0 remainder. Okay, colors don't want to cooperate. 0 remainder. There we go. All right, so the question, going back to the question asked us, is x minus 2 a factor of p of x equals x to the fifth minus 32? So the answer would have to be yes, it is a factor because we have no remainder. So we could say that x minus 2 is a factor. All right, the next part says if it is, which it is, now we know it is, write p of x as the product of two factors. All right, well, the product of two factors. Well, we know that if we multiply x minus 2 to x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16, we multiply these two things, it's going to equal x to the fifth minus 32. So if they want p of x as the product of two factors, then the way we can write it is to say that we could say that p of x is equal to x minus 2 times x to the fourth plus 2x cubed plus 4x squared plus 8x plus 16. Okay, so that's p of x as the product of two factors. And if we multiply that together, we get the x to the fifth minus 32. Okay, just one other thing to show you here. We'll call it the factor theorem. Okay, and what that says is that Okay, so factor theorem, if P of A is equal to 0, then x minus A is a factor of P of X. Let's take a look at that theorem in terms of this problem. All right, so we were dividing by x minus 2. So that's our x minus A, right? We were dividing by x minus 2. That's our x minus A right there. Now they're saying if P of A is equal to 0, well, in this case, A is 2. So if P of 2 is 0, and we'll figure that out now. We have x to the 5th minus 32, right? So we want to see if P of 2 is equal to 0. So that means we have to put 2 in for x. Okay, 2 to the 5th is 32. So P of 2 is equal to 0. So using the general form, if P of 2 is equal to 0, then x minus 2 is a factor of P of x, which in this case is x to the 5th minus 32. So being that we got a 0 here when we did P of 2, that tells us that x minus 2 is a factor. Okay, we would have had to divide anyway because they wanted this as a product of two factors, so we had to divide anyway to get our quotient as one of the factors. But had they not asked us to do that, if all they wanted to know is x minus 2 a factor of P of x, this would have been a good shortcut. The factor theorem would have been a good shortcut to get that answer. All right, so they want to know, is x to the 4th minus 1 a factor of P of x equals x to the 5th plus 5x to the 4th minus x minus 5? If it is, write it as a product of two factors. So same thing as before. We've got to create placeholders here. So x to the 4th plus 0x cubed plus 0x squared plus 0x minus 1 into x to the 5th, 5x to the 4th. We have to get a placeholder for the cube, 0x cubed. Same thing with x squared minus x minus 5. Okay, so we want to see how we're going to get x to the 5th by multiplying to x to the 4th. So that's going to be an x. I'll put that in the x to the 1st column. X times x to the 4th, x to the 5th, x times 0x cubed would be 0x cubed. And we have 0x squared. I'm sorry, this one's to the 4th power, this one's to the 3rd power, and then 0x squared minus x, right? Yes, minus x. Okay, change signs. All right, so that's going to give us a remainder of 5x to the 4th plus 0x cubed, 0x squared minus 0x. And take a remainder. So we have 5x to the, no, that is the remainder, excuse me. Bring down the negative 5. Now I need something that's going to multiply to x to the 4th. So that will be a positive 5. So we have 5x to the 4th plus 0x cubed plus 0x squared plus 0x minus 5. And this was a 0x. Okay. Have no remainder. So remainder is 0, which means that x to the fourth minus 1 is a factor. Okay. So our p of x in terms of the product of two factors is going to be p of x is going to equal x plus 5 times x to the fourth minus 1.